Hello everyone, how we doing? Today we're going to talk about the moon, and the moon definitely is an interesting topic. Obviously we've been there a few times. So we had 1969 was the first, as you see the picture there. Also, we're going to talk about the patterns we see from Earth as we're looking out at the moon. So what happens on a day-to-day basis, and also what happens with it monthly. And what other effects it can have on the Earth. First off, I want to show you a picture here. This is actually Mars. You can see a little bit of a red dot there. But basically, sometimes the moon can be a good marker to find the planets in the sky. So actually, recently, they actually had the parade of the planets. You could actually see Venus, Mars, and I think Jupiter all in a line with the moon one day. It was kind of an interesting sight to see. But either way, let's talk about the moon and see what the patterns are with it. Okay, so the moon, 27 1/3 days to revolve around the Earth, and 27 1/3 days to rotate on its axis once. Now, what does that do? The reason why I'm showing you two dancers. Dancers often face each other when they're dancing. So think of the Earth and the moon basically dancing together. The moon is slowly rotating as it revolves, that we see the same side of it, and that's why we see the same side of the moon always. The back side of the moon has only been seen by astronauts or by satellite photograph. So we always see the same face of the moon, the same craters, and the reason why, because again, the moon rotates 27 1/3 days and it revolves 27 1/3 days. Half of the moon is always lit up by the sun, just like Earth. But the amount we see of it lit up changes, and we'll talk about that. That's called phases of the moon. The moon rises and sets 50 minutes later each day. We said that already from the other PowerPoint we talked about the other day. There is a pattern to the moon phases, okay, and this is always the order. It goes around counterclockwise. So start always with the new moon, and then you go through each of them. So the next phase would be waxing crescent, first quarter, waxing gibbous, full, waning gibbous, third quarter, and waning crescent. And the pattern is waxing is always the right side lit up, and then the waning ones are the left side lit up, including sometimes it says third quarter, it's also called the last quarter. I'm going to show you a way to remember that in a moment. All right, so the changing phase of the moon is the amount of lit moon seen from the Earth caused by the moon revolving around the Earth. The moon takes 27 1/3 days to revolve around the Earth. The moon phases, though, takes 29 1/2 days. There's a slight lag between those two numbers. And the reason why is because, remember, the Earth and the moon are revolving around the sun, changing their position relative to the sun. So that's what causes that slight lag between the 27 1/3 and 29 1/2. Okay, going through each phase just so we know what they are. So new moon is the unlit portion of the moon facing the Earth. Now, you normally can't really see this. What you see in the sky sometimes is a reflection off of the Earth's surface. We call that Earth shine. So sometimes you'll see a slight faint light in the sky while the new moon is supposed to be occurring, and that's what that is. So light skimming off of the moon and coming to the Earth. Waxing crescent, so right side crescent a few days after the new moon, thin sliver of the moon is on the right side. First quarter, again, it's not called a half moon, it's called a quarter moon, because we're only seeing a quarter of the lit surface that's facing us. The other quarter is facing away from us. So this is about 1 week after the new moon, and so that's why it's not called a half moon, because again, you're only seeing a quarter of the lit surface. And next is waxing gibbous, so almost a full moon, not quite. There's a sliver of black on the right side if you complete the circle here. Hard to see that, but that's what the waxing gibbous is. And about a week after the first quarter, 2 weeks after the new moon, we have the full moon. Okay, so that's fully lit up. It's actually not the best time to look at the moon. You can actually see it's very bright, so getting a picture of the moon actually during the full moon is not the best. It's actually best to get it during the quarters. So take a look when we look at the next quarter again. So waning gibbous, a few days after the full moon. Now the left side is lit up. The sliver of black is on the right side now. And then the last or third quarter. So again, left side lit last, and you can see this is what I was talking about. You can actually get a better picture on the quarters. You can see it comes out nice and clear, and you can see the craters nicely. So that's a week after the full moon, and then we're heading to the waning crescent. That's a few days after the last quarter. And less of the lit side is visible, and it's still on the left side. The rest is all dark. And what happens after this? Well, it starts a cycle over again, and then you have the new moon again. Also little things to remember. Left side lit last. That's a good way to remember. Last quarter is the left side lit up. First quarter is the right side lit up. And kind of paying homage to one of my favorite movies, Karate Kid.
Wax on, right hand. Wax off, left hand. Wax on, wax off.
The reason why I play that is that wax on, wane off is a way to remember. Waxing means to get brighter, and then wane off, waning away means to get darker. And that's what happens during the wax on, wane off, as I think of it. Okay, eclipses for next topic. Eclipses are basically when there's shadows that block out either the moon or sun. So the lunar eclipse is an eclipse of the moon. That's when the moon moves into the shadow of the earth during the full moon phase. It's a little over an hour, about 100 minutes or so. And again, that will almost blacken the moon out totally. It usually turns a reddish color instead. I'll show you pictures in a moment. And then we have the solar eclipse, which is an eclipse of the sun. That's a new moon actually coming in front of the Earth's sunlight, the sunlight coming towards the Earth, and actually can totally darken out most of the sun and just leave the corona around the edge of the sun. And that casts a shadow on the Earth's surface that lasts about 7.5 minutes or so for total darkness, and it only happens in particular places. So if it's a particular place on the Earth, it's usually about once every 100 to 200 years for a location on Earth. So it's a very rare event if you get the total solar eclipse. We did have a partial one not too long ago, but we didn't get the total shadow of it. I think it went through Georgia all the way up in a diagonal towards Oregon in the country. Okay, what happens when the Earth, Moon, and Sun line up? So this is the first type of eclipse. This is the lunar eclipse. So an eclipse of the moon during the full moon phase. So the full moon, remember, is when it's Sun, Earth, Moon. The way you remember that is SEM. And it's basically the moon being blocked out by the Earth's shadow. And if it ends up in the umbra, which is the bigger part of the shadow, you end up with a total lunar eclipse. If you end up in the penumbra, that means it will only block out part of the light. Okay, and that's what it looks like, usually the reddish color, as I mentioned. There's a couple of YouTube links I'll put up on the description that you can take a look at of live ones. Solar eclipse is an eclipse of the sun, and it's during the new moon phase. The moon blocks out the sun during the daytime, and it goes sun, moon, earth. So you get the shadow on the one part of the earth. So the way to remember that is SME. So, and there's two different types. There's a total solar eclipse, which again, you only see the corona edge of the sun, which you're not supposed to actually view directly because again, that sunlight is very concentrated and can damage your eyesight. And the same thing, partial solar eclipse would be when the moon blocks out part of the sun, and you can see it's not fully blocking it out with the shadow. And that's what we saw here up in New York. All right, so that's a lunar eclipse. That's a total solar eclipse. That's a partial solar eclipse. Okay, and there's a couple of links I'll put up. Same thing with tides. I have a tide movie that I'll let you guys look at. And again, it's really cool. You can see the Bay of Fundy, which has the greatest tidal range in the world, around 50 feet, which is impressive. You'll see. But tides are a cyclic rise and fall of the ocean waters. And for most locations on Earth, it's 2 high tides, 2 low tides a day. It's around 6 hours. If you want to be exact, it's usually 6 hours and 13 minutes or so. So it's not really exactly 2 high tides, 2 low tides. It's actually a little bit spill over into the next day. But 6 hours and 13 minutes, and then from high tide to low tide. And then if we go high tide to the next high tide, it would be 12 hours and 26 minutes. For most locations on Earth. And there's a couple weird places where they have 2 tides a day. I think the Gulf of Mexico is one of them. But other than that, most places that's going to be the pattern. Tides are caused by the gravitational pull of the moon and sun on the water, so it's not just the moon. The sun is also tugging on the water on the Earth. And the moon is revolving around the Earth, and the Earth's rotation. Those are the 2 things that actually cause the tidal changes. Tidal changes that happen on the daily basis obviously are going to be rotation, and then on the monthly basis the tidal cycle will be due to the revolution. So during the month, because of the revolution, spring tides and neap tides happen. And spring tides have the greatest tidal range. These are the highest high tides and lowest low tides of the month. And again, because the moon's revolving around the Earth, the 2 phases that you get the strongest tidal pull would be during the new and full moon, because the moon, sun are pulling in the same direction or same plane. And I'll show you a picture in a moment showing the way that works, but basically those 2 phases are going to be the greatest tidal changes, and fishermen say those are the best times to fish during the month because the water will actually move the most and the fish will be more active. Neap tides, on the other hand, are the lowest high tides, highest low tides, the least tidal range. That's the first quarter and last quarter. The moon and sun are pulling at 90 degrees from each other, so they're kind of in a tug of war, the opposite directions, and as a result, you end up with weaker tidal cycles. Okay, so here's how it works. So the moon's pulling on the Earth, pulling the water outward on the one direction, and then the other direction, because the Earth spins, is something called centrifugal force, which ends up causing a bulge on the other side. So there are 2 bulges of water, and that's the way it works with the tidal cycle. Okay, a spring tide, again, I said the moon and the sun are pulling in the same line. This is the new moon. Also, the full moon on this side would also pull in the same direction. But you're going to say the sun and the moon are pulling opposite directions in that, but that's not the case, because remember, centrifugal force also acts on the water surface. So no matter what, you get 2 bulges on each side. So it doesn't matter if the moon's here or on this side for a spring tide. Those are both strong tidal cycles. And same thing with a neap tide. Except that it's pulling opposite. So here's the sun pulling this way, the moon is pulling this way, or this way, because it would be the first quarter or last quarter. And again, that's going to be a weaker tidal cycle as a result. Okay, and lastly, I want to leave you with this idea. Earth phases. Okay, if you are on the moon looking at the Earth, which is kind of fascinating, you'll see Earth phases instead of moon phases. The phases are exactly opposite of what the moon phase is. So if it's full moon, it would be new Earth phase. If it's a first quarter moon, it will be a last Earth phase. So kind of a really cool thing. And the astronauts that went on the moon, they snapped this picture from the moon where you can clearly see the quarter phase of the Earth, which is really cool. And just a little funny comic. Revolve, revolve, that's all you ever do. Why can't you leave me alone? That's what the Earth is saying to the moon. And there is a moon song online, which I'll put up a link to, which is actually kind of fun. So I encourage you guys to listen to it. All right, hope you guys enjoyed, and again, just keep working. All right, I'll talk to you later. Bye.